All right, how do we calculate the opportunity cost of something based off of a production possibility frontier? Okay, now in order to illustrate this, here's an example, right? So we have the production possibility frontier for a farmer who can grow different quantities of apples and bananas, right? So here's their production possibility frontier. So you can see that if they focused all their resources on growing bananas, they could grow up to 15 bananas. And if they focused all their resources on apples, they can grow up to 20 bananas, or they can grow some combination in between anywhere on that line, on the production possibility frontier, right? Okay, now to do this, in order to calculate the opportunity cost from the production possibility frontier, what we're going to want to do is find its slope, right? So the slope of the production possibility frontier, because it just so happens to be the case, and I'll explain why later, that the absolute value of the slope gives you, the absolute value of the slope of the production possibility frontier gives you the opportunity cost of the good that happens to be on the horizontal axis, right? So if we can find the slope and find the absolute value of that slope, then we can find the opportunity cost of the apples in terms of how many bananas have to be given up per apple, right? Okay, so the slope here, again, slope is, we define it as rise over run, how much you move vertically in order to move horizontally along the production possibility frontier. Well, the easiest way to calculate that is to just look at what happens, what is the slope, what is the rise over the run, going from one intercept to another, right? So let's say we're going from the point where we have 15 bananas and 0 apples to the point where we have 20 apples and 0 bananas. All right. So the rise here is how much you move vertically, which means how many bananas you're going to be giving up, right? Since you're going to be giving up bananas. So the rise is going to be negative 15, and it'll actually be useful to keep track of our units here, right? So negative 15, we're losing bananas, right? So the rise is negative 15 bananas. We're losing 15 bananas. We're decreasing by 15 bananas. And then the run, well, how much we move horizontally is 20. And again, keeping track of the units, we're gaining 20 apples, going from this point to that point. We're losing 15 bananas, but we're gaining 20 apples, right? So the run is 20 apples. And we can reduce this, right? The 15 over 20, well, that's a negative. The negative 15 over 20 is a negative 3/4, right? And then the units are bananas divided by apples. So we can rewrite that as basically bananas per apple. Bananas per apple, right? So the slope here is essentially negative 3/4 bananas per apple, right? Okay, now let's think about this another way. Let's think about this as opportunity cost. Remember, opportunity cost, one way to calculate it is to think about what is given up and what is gained and divide what is given up by what is gained, right? And that will give us the opportunity cost. Okay, well, again, going from the same point, the y-intercept to the x-intercept, the bananas intercept to the apples intercept, we're going from having 15 bananas and 0 apples, producing 15 bananas and 0 apples, to producing 0 bananas and 20 apples. So what we give up going from this intercept to this intercept is, well, we're giving up 15 bananas, right? And again, keeping track of the units, we're giving up 15 bananas, and we are gaining 20 apples, right? Go from 0 apples and 15 bananas, 20 apples and 0 bananas. So we gain 20 apples. And this should look familiar, right? It's essentially what we did above, just without the minus sign. And so again, we can reduce this to 3/4 of a banana per apple, right? And so you can see that the opportunity cost is the same as the slope, just without the negative sign, right? So that's why we take the absolute value of the slope, and that gives us the opportunity cost of the good that happens to be on the horizontal axis, right? Now let's talk about why is that the case, right? So, well, it happens to be the case because when you're talking about the opportunity cost of a good, you're talking about how much of one good you have to give up in order to get that good, right? So it's given up divided by gained. So we're going to be talking about how many bananas you have to get in order to gain apples, right? So that's why the units are bananas per apple. And the units happen to match up with the slope, right? And the slope happens to be rise over run. So it's bananas per apple, so negative 3/4 of banana per apple. So the units match up, and it just happens to be the case that the numbers match up as well, because the rise happens to be what is given up, and the run happens to be what is gained. It's just you drop the minus sign, right? Another thing to think about that I can illustrate with this example is that if you ever have a problem when you're dealing with some goods, it doesn't have to be apples and bananas, it could be anything, right? Generic X and Y type goods, whatever. If you have to calculate the opportunity cost of a certain good, well, then you're going to want to put that good on the horizontal axis, right? Because then once you find the slope, then taking the absolute value of that slope will give you the opportunity cost of that good that you put on the horizontal axis. If you didn't do that and you put it on the vertical axis, well, then the slope that you find would actually be the inverse, right? It'd be the multiplicative inverse of the number you're looking for, right? So if we were to have bananas over here on the horizontal axis and apples over on the vertical axis, this slope would have been a negative 4/3 apples per banana, right? Apples per banana, 4/3 of an apples per banana. And that wouldn't give us the opportunity cost of apples. That would have given us the opportunity cost of bananas, right? So again, you want to think strategically about which good is it that you need to find the opportunity cost of, and in order to have one less thing to worry about, one less step in the process, you can go ahead and put that good on the horizontal axis. All right, thank you for watching.